In this video, I'm going to try and explain the concept of stoichiometry and what that is and what it means in chemistry. It's extremely important in all of chemistry and is a very fundamental aspect of chemical reactions. And sometimes it can be really hard to understand what you're actually doing when you're calculating stoichiometry problems, so I'm going to try to explain it using something you're more familiar with. So the whole basis of stoichiometry is it's used to calculate amounts of reactants or products. So we're going to come back to that definition. I want to use something a little bit more familiar to most people. Let's talk about s'mores. So if you're gonna make s'mores, you need ingredients, right? You need graham crackers, you need chocolate, and you need marshmallows. And this is my perfect recipe for what I think is the perfect s'more. 2 graham crackers, 3 pieces of chocolate, and 1 marshmallow. Let's pretend we were trying to turn this into a chemical reaction. So if these were the symbols for each of our ingredients, it would look something like this. 1 marshmallow plus 3 pieces of chocolate plus 2 graham crackers would form 1 s'more. So let's think back about this definition of stoichiometry. It's used to calculate amounts of reactants or products. Well, these are reactants, and this would be our product. So stoichiometry would be the process of calculating how many of each of those things that you might need. For example, you might be asked, how many graham crackers does it take to make 25 s'mores? And most of you could probably figure that out pretty easily. If you want 25 s'mores, each s'more requires 2 graham crackers. Well, that means you would need 50 graham crackers total to make that many s'mores. You might also be asked something like, how many s'mores could you make from 3 chocolate bars? So if you have 3 chocolate bars, you might want to know, how many s'mores could I make out of that? Well, if 1 chocolate bar has 12 pieces, 1 chocolate bar can make 4 different s'mores. And then if I have 3 chocolate bars, that means I could probably make around 12 s'mores. So it's really just a relationship of how much stuff you could make using the ingredients that you have. This same concept applies to chemical reactions. If we want to know how many grams of H2O can be produced from a certain amount of hydrogen, then we're going to do stoichiometry to figure that out. Maybe we want to know how many grams of oxygen would I need to make a certain amount of H2O, and we can figure out both of those answers using stoichiometry. So when we're doing stoichiometry, there's a lot of steps, unfortunately. But let's say that our chemical reaction looks something like this. This is very generic. But the goal of stoichiometry would be to get from grams of A to grams of B. That's what we're trying to find out. How many grams of this would make a certain number of grams of that? The first thing we're going to have to do is convert our grams of A to moles. Once we have moles of A, then we can use our mole ratio. Remember, the mole ratio is a conversion factor between the numbers of moles of 2 substances in a reaction. So we can use our moles of A to figure out how many moles of B we should have. So our next step is to use the mole ratio of A to B, and we're going to put A on the bottom because we want those units to cancel out. And we're going to use that to figure out the moles of B. And once we have the moles of B, we can use that to figure out the grams of B. And that is all of our steps from start to finish. Grams of A convert to moles, use the mole ratio to convert to moles of B, and then we're going to convert back to grams of B. So let's see what this is going to look like as a T-chart. Your given is going to be your grams of A This first step is going from grams to moles. How do we convert from grams to moles? Well, we're going to have to use the molar mass. Remember, this is what our conversion factor looks like for molar mass. So in our T-chart, since we have grams here, we're going to need the grams to go on the bottom. And in that blank is where our molar mass of A will go. And since our molar mass is equal to 1 mole, then the top will be 1 mole of A. The next step is to go from moles of A to moles of B, and we use that mole ratio to figure that out. So the mole ratio, we're going to take the moles that we're starting with is going to go on the bottom. And the moles that we're trying to get to will go on the top. And the way we figure out what goes in these blanks is from the balanced chemical reaction. Once we've filled in that mole ratio from the balanced chemical reaction, the last step is going to be to convert back to grams of B. So again, we're using that conversion factor for molar mass. The difference is this time we're talking about substance B, not substance A. So this time my 1 mole is going to still go diagonal, so that means the 1 mole is still going to go on the bottom. And my number of grams is going to go on the top. And that is where my molar mass goes. Let's just make sure all of our units cancel out. So we have grams of A and grams of A. We have moles of A, moles of A. And finally moles of B and moles of B, which leaves us with grams of B, which is what we were originally looking for. So this would be our full setup for stoichiometry.